What if I told you that the moon is slowly dying of rust? Right now, a chemical infection is spreading across the lunar poles, 384,400 kilometers away. NASA data confirms massive patches of hematite, heavy iron oxide, are forming on a world with no air and no liquid water. But rust is chemically impossible in a vacuum. It requires oxygen. So, if the moon is dead, who is painting it red? The answer might be Earth. This discovery breaks the fundamental laws of space science we've relied on for 50 years. Here is the reality. The moon is constantly bombarded by the solar wind. This is a stream of hydrogen ions shooting from the sun at nearly 1,000,000 miles per hour. Chemically, hydrogen is a reducer. It strips oxygen away. It keeps iron metallic and shiny. It prevents rust. Finding rust on the moon is like finding a dry piece of paper at the bottom of the ocean. It physically shouldn't happen. Yet, a study published in Science Advances proves it. Hematite is spreading across the high latitudes of the moon. Scientists at JPL were genuinely baffled. One researcher stated that the moon is a terrible environment for hematite to form. So, is the moon generating its own atmosphere? Or is something sinister happening in the dark? To understand why this is such a nightmare for planetary models, we need to look at the normal science. Rust is iron oxide. On Earth, it's inevitable. We have a damp, oxygen-rich atmosphere. Iron reacts with oxygen and water to form reddish dust. But the moon is an airless world. Its atmosphere is a tenuous exosphere, where atoms barely interact. Since the Apollo samples came back in the 1970s, we've known a core fact. Lunar iron is metallic. It's elemental. It hasn't rusted, because there is no oxygen to react with. This is where things get strange. In 2008, the Chandrayaan-1 orbiter arrived at the moon carrying a NASA instrument called the Moon Mineralogy Mapper, or M3. M3 was designed to scan light spectra to identify minerals. For years, scientists analyzed this data looking for water ice in shadowed craters. But when they looked at the polar regions, they found a spectral signature that didn't match water, and it didn't match metallic iron. It matched hematite. Hematite requires free oxygen to form. The moon shouldn't have any. The mystery isn't just what is it, but how did it get there? If the solar wind is constantly scrubbing the moon clean, something else must be overpowering the sun itself. The detective story begins with Shuai Lee, a researcher at the University of Hawaii. It was 2018. Lee was combing through the M3 data looking for hydration signatures, but he kept seeing absorption lines in the spectrum that looked wrong. They looked like rust. Lee was skeptical. He knew the physics. He knew rust shouldn't be there. So, he teamed up with colleagues at NASA's Jet Propulsion Laboratory to double-check every pixel. The result came back positive. It was hematite. But the team noticed something else, a clue that cracked the case wide open. They mapped the location of the rust. If the rust was caused by ancient water inside the moon or by asteroids hitting the surface, it should be scattered randomly. It wasn't. The hematite was heavily concentrated on the near side of the moon. You know the near side. It's the face of the moon that is tidally locked, always pointing at Earth. Stay with me here, because this geometry is the key. If the rust is facing us, the cause must be coming from us. But Earth is nearly 400,000 kilometers away. Space is a vacuum. How does oxygen travel across the void to infect a rock that far away? It turns out Earth has a hidden weapon. Earth acts like a giant magnet. We generate a massive magnetic field that protects us from the sun. But the solar wind pushes on this field, stretching it out on the night side of Earth into a long, tapered shape called the magnetotail. Think of it like a windsock trailing behind a moving car. Once a month, during the full moon phase, the moon's orbit takes it directly through this magnetotail. When it enters this zone, the physics of the moon change completely for about 5 days. Two incredible things happen. First, Earth's magnetic shield blocks the solar wind. That constant bombardment of hydrogen, the anti-rust agent, stops. The moon's defenses are down. And then, the invasion begins. Second, Earth is leaking. Sunlight hits Earth's upper atmosphere, energizing oxygen atoms. Some of them escape gravity and travel down the magnetic field lines. This is called the Earth wind. So, for 5 days a month, we blast the moon with a shower of high-energy oxygen ions. This oxygen travels 384,000 kilometers and slams into the lunar soil. Because the solar wind isn't there to scrub it away, this oxygen has time to react. It bonds with the iron in the regolith. We are literally rusting our own moon from a distance. Shuai Li's study suggests this has been happening for billions of years. This explains the near-side concentration perfectly. It's the side facing the hose of oxygen. It's a perfect explanation. It fits the data. But science is never that simple. Just when you thought you understood the mechanism, the data gets messy. While the near side is covered in rust, M3 also found trace amounts of hematite on the far side of the moon. Think about that. The far side never faces Earth. It never sees the Earth wind. It is constantly shielded from our atmosphere by the bulk of the moon itself. So why is it rusting? If Earth is the cause, the far side should be pristine metal. This implies a secondary culprit is at work. Scientists believe that tiny dust impacts, micrometeoroids, are hitting the poles. These impacts flash vaporize tiny water ice molecules trapped in the soil. This releases a microscopic puff of oxygen right at the surface level, allowing rust to form instantly. But here is the twist. The near side is still significantly rustier than the far side. This proves that while local water helps, Earth is the main villain in this oxidation story. It's a cosmic tug-of-war. The sun tries to keep the moon gray. Earth tries to turn it red. And right now, we are winning. This matters for more than just geology nerds. This rust is essentially a 4.5 billion-year-old hard drive. Since Earth has been leaking oxygen since the atmosphere formed, the layers of rust on the moon might record the history of our own planet. We could drill into the moon to find out what Earth's air was like during the time of the dinosaurs, or even before life began. But it also has a practical consequence. For the upcoming Artemis missions, this is a headache. We plan to refine lunar soil to build bases and extract oxygen. Rust is chemically different from metallic iron. It changes how we process materials. NASA engineers now have to account for weathered soil on a world with no weather. The good news is, we don't have to guess for much longer. NASA's Artemis program and robotic scouts, like the Viper rover, are targeting these polar regions. They will be able to sample these hematite regions directly. We are going to ground truth this theory. This proves that our solar system is a dynamic, interconnected living system, not just a collection of lonely rocks. Remember? The universe is full of rust, but it's the shiny parts that catch our eye.